a body of specific heat capacity, 450 joule per kilogram per Kelvin, falls to the ground from rest through a vertical distance of 20 meters. Assuming conservation of energy, calculates the change in temperature of the body on striking the ground level. So we need to calculate the temperature of the body on striking the ground level. We need to do something here. See, assuming conservation of what? Energy. Assuming conservation of what? Energy. Meaning energy can be converted from kinetic energy to potential energy, and conversely from potential energy to kinetic energy. That's what it means. Alright? Okay, so let's begin. We have solution. We need to, yes, we need to outline this solution we're going to use here. First of all, specific heat capacity of the body is given as 450 joules per kilogram per Kelvin. So C is 450 joules per kilogram per Kelvin. That's the specific heat capacity. And then next is falls to the ground through a vertical distance. That's height. H. Okay? H is given as 20 meters. For the fact that it's falling from a height, that means we must have something to do with acceleration due to gravity, which is G. G is given as 10 meters per second squared. Can you see that? But it's not given here. It's not given. But if you are smart, you should know that any object falling from a height, no matter how small the height is falling under the influence of acceleration due to gravity. Alright? Okay, so what next? That's this. We've considered height, acceleration due to gravity, calculate the change in temperature of the body on striking the ground level. We must find out the change in the temperature of the body, which is theta 2 minus theta 1, or theta 1 and theta 2, so to say. Alright? So what next? For us to be able to solve it, we must take into consideration assuming conservation of energy. Okay? We must assume conservation of energy, whereby potential energy, which is given as PE, can be converted to kinetic energy, which is given as KE, and vice versa. This could go this way, alright, and this could go this way. That's what it means. So let's see how we can convert this from potential to kinetic, or from kinetic to potential, for us to be able to solve this. Alright? So that is it. And if we do that, since it is falling from a height, we have only kinetic energy. So kinetic energy is now equated to the heat parameter of the body. Yes. They say we should calculate. We should calculate, okay? So if that is the case, and we have kinetic energy, potential energy, right? So let's do something here for clarity purpose. Now we have potential energy is mgh. Kinetic energy is half m and then v squared. So which one concerns us here? How do we now get the temperature change? Because there's no temperature here, but there's something that the question said. Assuming conservation of energy, meaning it's converting from potential to kinetic, from kinetic to potential, until, look at, on striking the ground, what happens? What happens? Okay, so we have mass, we have acceleration due to gravity, we have what? Height, and that is this. That means the object is converting from kinetic energy to potential energy. We will make use of potential energy, which is given as PE is equal to what? MC, and then change in temperature. Okay? We can still restate this as PE, which is MC specific heat capacity, all right? Change in temperature theta 2 and the theta 1 bracket close. That's what it means. So with this, in place of potential energy, we have mgh, and then here we have mc bracket theta minus theta 1, right? There's a temperature change. So we're actually looking for this, okay? We can make this the subject. What do we do next? We cancel out. M, mass of the body, will cancel out. And we have GH, okay? So with this, we now have GH is equal to C bracket open theta 2 minus theta 1 bracket close. We can now make theta 2 minus this change in temperature. This change in temperature, we can make it the subject, okay? All right, if we do that, we can now have that change in temperature, which is theta 2 minus theta 1 is equal to G, okay, H, all right, all over C. Good. So proper substitution here. Let's just do substitution according to what we have. That's theta 2 minus theta 1. Substitution gives, for G it is 10, for height it is 20, right? All over. Look at it. Our G is 10, right? Height is 20, and then C, the specific heat capacity, is given as 450 joules per kilograms per Kelvin. 450 joules, okay? That's it. Now there is something you need to do. Yes, there is something you need to do, okay? Let's see. Okay, we might still do it. Let's just conclude. Let's just finalize what we started and see what this will be. If we use theta 2 minus theta 1 as change in temperature, right? 20 times 10 or 10 times 20. Look at this. 10 times 20 is going to be 200. We'll give 200. 200. All over 450. 450 is what? The specific heat capacity according to this transposition, right? Alright, so, okay, I think we're making progress here. We cancel 0 here, we cancel 0 there, and we have 20 over 25, over 45. 20 over 45. What happens next? 2 divide 20 is, okay, we can go with 5. 5 divide 20 is 4, right? Good. 5 divide 45. 5 divide 45 is 9. Yes, 9 times 5 is 45. So it should be 9, okay? We have 4 here and we have 9 here. Alright? And we're talking about the temperature change. That is theta 2 minus theta 1. This is a degree Celsius. Soft. So it's soft. We don't need this again. Soft. So the final answer is this. That's the final answer. QED, soft. So check which of the options is correct. So option A, 0 degrees Celsius. Option B, 2 over 9 degrees Celsius. Not it. Option C, take it again. Option A, 0 degrees Celsius. Option B, 2 over 9 degrees Celsius is not it. Option C, 4 over 9 degrees Celsius. 4 over 9 degrees Celsius. So option C is the correct option, right? This is the most appropriate option according to what we have here. So that is it. However, if you think the steps are not clear, do me a favor. Comment in the comment box. Give me some shares, some likes, subscribe. And then I want to read your comments. Indeed, yes, I want to read your comment. I want to know how you feel about all this that I've been dishing out all this while. Put your comment there. Tell me what you like or what you don't like. How much value I've found in this. Alright? I want to sign up now. See you next class.